Five. It says 9 women and 6 men are standing in a straight line. So you have 9 women and 6 men. How many arrangements are possible if any individual can stand in any position? So if you have 9 women and you have 6 men and they can stand in any position, then there are no restrictions. If there are no restrictions, it is permutation. Right? Arrangement is permutation. So 9 women and 6 men, that tell you for part A, n equal 15. That's for part A. Then what do you want? If they're standing in any position, it's just going to be 15 factorial. How do I know? You're permuting all of them. So 15 permute 15. I tell you it's just 15 factorial. All right, so you can use your calculator and write that out, but I'm just going to say there are 15 factorial ways. That's for part A. All right, if any individual can stand in any position. Let's look at part B. Part B says, in how many arrangements will all 6 men be standing next to one another? So for part B, the best way to do this is the box method. The box method allows you to see what is happening. Draw a box. And you know you need to cut it in. What is R? You're permuting 15 people. 9 and 6 is 15. 1, 2, 3, 4, 5, 6, 7, 8, 9. I might not have enough space. 10, 11, 12, 13, 14, and 15. This is it. That's 15. That's 15. And what do we know now? This is 15. And since this is 15, what do we know? In how many arrangements will all 6 men be standing to one another? So maybe the 6 guys are over here and the 6 guys are over here. I don't know. Let's choose an end. I like to go from left to right. So let's say one guy stand here. So if one guy stand here, any one of the 6 guy can go here. Any one of the 5 guy here, any one of the 4 guy here, any one of the 3 guy here, any one of the 2 guy here, any one of the 9 guy right, any one of the last guy stand here. So these are the 6 guys together, all right, are men. And then that means the women them over this side. So that means over here is your 9, your 8, your 7, your 6, your 5, your 4, your 3, you're 2, and I didn't have enough space then because that's not 15, then you're 1. Let's put the 1 right there. So now in total, if 6 guys are together, next to one another means together, then you think of togetherness as 1. So look at this as 9 women and 1 guy because the guys are together. So really and truly that's 10 factorial. Because the guys together, you think of them being together as 1, and then you add it to the 9 over here, so that's 10 factorial, but then you multiply it by the number of ways we can arrange the guys them. Number of ways we can arrange the guys them is 6 factorial. That's 6 factorial. And so that means part B answer is just going to be 10 factorial times 6 factorial. That's part B, ways. Nice. Part C, in how many arrangements will no 2 men be standing next to one another? So at no point in time do we want men to be standing next to each other. So no 2 guys should stand up next to each other. Wow, that's crazy. So part C, no 2 guys should be standing next to each other. So let's work that out. So of course, again, we'll cut it up in 15 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Nice. So remember, no two guys can stand up next to each other. No two guys. So if a guy start here, girl, then guy, then girl, then guy, then girl, then guy. All right. So what we can do is to get an idea of it is, let's say the first one right here is a guy. How many guys would be right here? Right? I'm going to use guy to start. All right. Guy don't sound right. Let's write men. I'm going to use M for men. If a man there at the end right here, so 6, then any one of the 6 can stand here. Then a girl would go here. 9. Then a man would have to go here, don't? Because no two guys can't be next to each other. And so then a man would come here, which is 5. Then a next girl make 8. Then a man would come here, so because now there are 4 men. Use M for men. 3 men right here. A man can come here. Then a man can come right here. 2. Then a man can come here. 1. Right. And in between, right here now, we can have our women. So 5 women can come here. 5 women can come here. Let's go again. 6, 9. How many women are here? So this is 8. So 7 women. 6, 5. Then we know our 4, or 3, or 2, or 1. Nice. So that's how you distribute it, so that no two guy is ever beside each other. All right, we don't want no guy to be standing next to each other. So then all you have to do is multiply that out now to get your answer. All right, so you multiply out 6 times 9 times 5 times 6 times 9 times 5 times 8 times 7, 8 times 4, sorry, times 7, times 3, times 6, times 2, times 5, times 1, times 4, times 3, times 2, times 1. When you work out all of that, what you get is 6 times 9 times 5 times 8 times 4 times 7 times 3 times 6 times 2 times 5 times 1 times 4 times 3 times 2 times 1. I get 261, 273, 600 ways. That's the amount of ways where no two guys stand next to each other. All right, nice. This is Ronaldo Ferguson's computer shop. They sell 10 different types of computer. A customer wishes to buy 6 computers of different brand. It says calculate the number of ways a customer may make his or her selection. So making your selection, right? It didn't give us, once you see selection, it's combination. Now, how many the customer want to buy? 6. How many different types of computer is being sold? 10. And so it's going to be 10, choose 6. Because the customer want to buy 6 computer out of these 10 different types. So that is what it's going to be. So just put in our calculator, 10, choose 6. 10, wait, 10, shift, choose 6. 210. That's 210. So there are 210 ways for the customer to choose 6 different brands. That's it. It says off. Again, I'm not an English teacher, so bear with me. Of the varieties there are 3 Dell type computers, 5 Acer type, and the next 2 are HP type computers. Calculate the number of ways of the customer selection of 6 computers that could contain no Dell. If the customer don't choose no Dell, that means the customer is choosing 0 Dell from how much Dell did there? 3. There are 3 Dell. The customer don't want no Dell. So I'm choosing 0 from 3 times how many other computer left back? 7. And then I'm choosing 6 out of that 7. All right. And that would be choosing no Dell computer because the customer is not choosing any of these 3 types right here. So the customer is still going to buy 6, but then from the remaining, either from the Acer and the 2 HP. So we'll just work out 320 times 7 choose 6. Let's work that out on our calculator. So it's just going to be 3 choose 0 times 7 choose 6. And we work that out, we get 7. So there are 7 ways of choosing no Dell. There are 7 ways. Nice. So there are 7 ways. Now it says at least 1 HP is chosen. At least 1 HP. To find out the number of ways of choosing at least 1 HP, that means the customer can buy what? If you choose 1 HP, you can choose 1 HP. How many HP are there? 2. The customer can either choose 1 HP from the 2 multiplied by, now how many computers are left to choose? 5. 5 from how much? 8. Yeah, man, because they have 2 HP. Plus, it says at least, there is also the possibility that the customer may want to choose both HP, so they're choosing 2 from 2, times, how many computers would be left? 4. 4 and 4 from remaining 8. So this would be the calculation for finding out of choosing at least 1 HP computer. So we work this out, and what we get is, let's go to our calculator. 2 choose 1. We choose 1, and that's being multiplied by 8 choose 5. Then we add that to, of course, 2 choose 2. 2 choose 2. Then we multiply that by 8 choose 4. That's it. We work that out. We get 182. Nice and easy. Soft 182. And that's the number of ways of choosing at least 1 HP computer. And it says, calculate the number of 6-digit numbers which can be formed using the digits 0 through to 5 without repetition, assuming that a number cannot begin with 0. So, first thing is, we're going to draw our box, right? So I want to choose a 6-digit number. This is how I like to do it, all right? So I like to break it up, 1, 2, 3, 4, 5, 6. That's a 6, this is 6-digit. And let's look at the possibility. This is how I like to do it. If the first number is 1, all right? So this is the case where I like to write cases. So I like to write case 1, where the first number is 1. If the first number is 1, or if the first number is 1, all right, if the first number is 1, and you can have 1 right here, there's only one way, then you'd be left back with 5 digits. So if any one of the 5 can go here, any one of the 4 can go here, anyone here, anyone here, and the last one there. Now that might sound confusing. If the first number is 1, then that means what we're left back with is 0, 2, 3, 4, and 5. So anyone can go right here, 0, 2, 3, 4, or 5. So that's where that 5 come from. When you choose one of these, it have 4. Then when you choose another, 3. Take another 2, take another 1. All right, so that's all the ways if we started with the number 1. So how many this work out to be? 1 times 5 factorials. There are 5 factorial ways. Now let's look at this now. How many ways if we start with 2? Any way you take it, look at this. So it's all going to be the same. Case 2. Case 2 is the case where we start with 2. Case 2 is if the first number is 2. If the first number is 2, it's still 5 factorial ways. Case 3 is going to be 5 factorial ways as well. Case 3, if the first number is 3, if the first number is 3, it's still going to be 5 factorial ways. Then case 4 is if the first number is 4, but then that's still going to be 5 factorial ways. And then case 5 is if the first number is 5, that's still going to be 5 factorial ways. And so add up all of that, and that will give you how many 5-digit number we can find. All right. How many 6-digit number that is, sorry. So the number of 6-digit numbers we can actually form. All right. So the number of 6-digit numbers, that's going to be equal to 5 factorial plus 5 factorial plus 5 factorial plus 5 factorial plus 5 factorial. I'm just going to write it as 5 times 5 factorial. That's the number of 6-digit numbers. 5 factorial is, I can't remember, so I have to work it out. 5 times 5 factorial. 5 times 5 factorial is 600. Oh, didn't I remember it was 120? 600. So there are 600 6-digit numbers that can form from these 6 digits up here. Nice. Now the next part of the question says, also, how many of these 6-digit numbers are even? How many of these 6-digit numbers are even? Now, to determine how many of these numbers would be even, I like to draw my box. All right, I like to draw my box. And so if it's going to be even, then we know that the 6-digit number that was formed, 1, 2, 3, 4, 5, 6. Then we know that, guess what? If it is even, it can either end with a 0, a 2, and a 4. It can end with either a 0, 2, and a 4, right? That's the only way it can be even. So any one of the 3 number them can go here. So, but guess what? It absolutely cannot start with 0. Cannot start with 0. So first thing you do is take out the 3 right here. It cannot start with 0. Since it can't start 0, I will know I'll have an even number here. So then how much left back here? It can't start with 0. All right. So if you want to do even, all right, let me not do it this way. I'm going to do it another way. Since I was doing it by the cases, let's continue with the cases. In the case where it started with 1, this is case 1 when we start with 1. And let's look at the case when you go 2, 3, 4, and 5. In the case where it starts with 1 again, it can end with either a 0, a 2, or a 4. Anyone can go here, so that's 1, 2, then we left it back with 4 number right here, so we'll choose this one and this one. So 4 can go here, so 3 can go here, so 2 can go here, so 1 can go here, so. All right, this is 7 digits, so let me cut off piece. Need to cut off this piece right here. Yeah. Put 3 better. So this would be the number of even numbers when it starts with 1. That would work out to be 4 times 3 is 12, times 2 is 24, times 3 is 72. That's the number of even numbers that can be formed when the first number is 1. What about when the first number is 2? When the first number is 2, then the even numbers can end with either 0 and 4. So that would be 2 right here. This would be 1 right here. Then in between here, you have 4, 3, 2, and 1. This would be 1 times 4 is 4, 4 times 3 is 12, 12 times 2 is 24, 24 times 2 is 48. So what happens is when we start with 2, there's only 48 even numbers. Why is that? Because the n number can then either be 0 or 4, but it cannot be 2 since we're starting with 2. Number of even numbers for 3 now, we'll start with 3, and we can end with either 0, 4, or 2. So this is 3 right here, and it's going to be 4, 3, 2, and 1. So that's 72. Soft. Number 4. Case 4. If it starts with number 4, then it can either have 0 or 2 at the end. So then this is just going to be 4, 3, 2, 1. Multiply them there across, you get 48. Case 5, meaning when it can start with the first number 5, but end with an even number, this is going to be 72. So you add these up, and then that would give you how many even numbers there are. 72 plus 48 is 120, plus 72 is 192, plus 48 is 240, plus 72, that is 312. So there are 312 out of the 600 numbers that are even. That's 312 even numbers. Easy. Soft. That's this example right here.